Welcome to another 6Win demo. This demo showcases the strength of combining 6Win and Inside Secure to produce the next generation security gateway for cloud environments. The demo testbed comprises two identical servers with an Ubuntu OS running on an Intel Xeon E5-2680 V3 processor with 12 cores and 4 gigabit Ethernet interfaces.
We will install the IPsec software comprising of the 6Win Turbo IPsec data plane and Inside Secure QuickSec control plane, assigned with 8 and 2 CPU cores respectively.
The first test will determine the Security Gateway tunnel setup rate. Security Gateway 1 will run Inside Secure's perf tool. Security Gateway 2 is running Inside Secure QuickSec and 6Win Turbo IPsec. We will measure the Inside Secure QuickSec tunnel setup rate on Security Gateway 2. We will create a total of 50,000 tunnels. On Security Gateway 1, we set up the IP addresses, tune kernel parameters, and then we will start multiple instances of perftool. Security Gateway 2 does not have 6Win Turbo IPsec installed. First, we'll install the authentication credentials, and then we download Turbo IPsec from the online repository. We use the standard Linux package manager to install. Next, we allocate 8 CPU cores to the 6Win Turbo IPsec data plane and start it. We check the real CPU utilization and verify that none of the virtual CPUs are busy, since there is no data traffic. Finally, we configure the interface IP addresses and tune the kernel to improve performance. Inside Secure QuickSec is already installed. We start QuickSec with the XML configuration shown. At this point, the test is started and we will move to the graph plotting the test progress.
The plot comprises two curves. The blue curve shows the total number of tunnels built. The blue curve will flatten at the targeted 50,000 tunnel mark. The green curve is the tunnel setup rate. The average tunnel setup rate is 2,300 tunnels per second. This concludes the first test. The second test is a zero-loss throughput test. In this test, Security Gateway 1 acts as a security aggregator. The IPsec ports on the left are configured with 20 IP addresses each. Each IP address generates flows to 250 IP addresses. That's 5,000 flows per port. Each flow is encapsulated in an IPsec tunnel for a total of 5,000 IPsec tunnels per port, or an aggregate total of 10,000 IPsec tunnels. Since this test generates traffic in both directions, the IPsec ports on the right are configured with 5,000 IP addresses each. After cleaning up Security Gateway 1, we download and install 6Win Turbo IPsec. Next, we will apply the same data plane configuration to both security gateways. Now we will start Turbo IPsec and check vCPU utilization. The FastPass CPUs are idling. Now we set up the network and start up Inside Secure QuickSec and configure the control plane to create 10,000 tunnels. We confirm that the tunnels are set up by verifying 20,000 security associations and corresponding security policies. Now it is time to generate traffic. We bring up the IPsec GUI and start the test. We deliberately reduce the traffic rate to 95% of line rate to compensate for the IPsec overhead introduced when traffic is encrypted. The IPsec gauge indicates a transmit and receive rate of 37.7 gigabits per second using 1,420 byte packets. This translates to 40 gigabits per second of encrypted traffic between the security gateways. At the security gateway consoles, we will see that the CPU utilization is uniform across all CPUs at about 90%, which means we still have some room to grow. Finally, we verify that we have zero packet loss at line rate. In summary, the demo shows how Inside Secure QuickSec and 6Win Turbo IPsec are easily installed and integrated to provide a scalable, high-performance security gateway for cloud environments. That is all, and thank you for your patience.